going. So, my name is Nicolai, and I don't want to bore you, so let's start with JUnit 5. And while all these people settle in, I have a question. Who has been using JUnit, like, ever? Oh, wow, okay, great. Like, wait, keep it up. Who has been using JUnit last month? Last week? Like, today? Nobody? Oh, yeah, great, okay. I'm going to need all of your guys' help soon, so keep up the spirit. Quick heads up. What I'm talking about is JUnit 5, which is work in progress. The alpha version is out, and the milestone is going to be out very soon. There are some links which you can, where you can find more information. And this is a great opportunity to give feedback to the team and maybe get a feature that you always wanted implemented. That being said, I'm not actually implementing this stuff, I'm just talking about it, so I'm not a member of the team. Okay, we have a little ground to cover, and let's start with all the stuff, all the obvious stuff that is new. And this is where I need your help. What's new here? This is a compiling and running JUnit 5 test. Something is missing. Can you read it? Yes. Something is missing. Who can tell me what is missing? Great. No public anymore. Woohoo! So package visibility suffices to let our tests run. Less boilerplate. What's new here? Subtle. Exactly. The lifecycle methods have different names. But they work as before. They just have different names. What's new here? Disabled. What was it called before? Exactly. Now it's disabled. Otherwise, it's the same. So what's new here? Okay, you might guess that disabled on Friday is not actually in there. I wrote that. And it's really easy to extend it. And we'll see later how. But this is a cool thing. What's new here? Message comes last, exactly. It used to be in the front, which always bugged me, but now it goes in the end. And a small detail, the first nod to Java 8. Okay, this is so easy, I'll answer it myself. You can actually create the message by a lambda expression, so if you have something very expensive that you want to do only in the failure case, then you can just do it on demand and not always. Oh, yeah, failure messages can be created lazily. This is cool. Well, you can see what's new. It's assert all. Can you guess what it might do? Exactly, it gathers all results. So in case you have like 5 things you want to check, usually you get like the first failing assertion, and then you're wondering, what about these other 2 things? What did they do? And this is what happens then. Like it says, all of these failed, and this was what was expected. And even though the first one already failed, the other 2 were still checked. And you get all of these results. What's new? So this is my this method is somewhere in the code that I'm testing, right? And this is my test method for it. Exactly. So assert throws asserts that a specific exception is thrown. And expect throws is very similar. It just returns the exception, so you can do even more stuff. Not quite obvious why there should be 2 methods, but anyway, that's how it is right now. This is cool. What's new here? You're probably already seeing it and wondering what it might do. Exactly. So now you can easily nest these classes, and you just tell JUnit with nested, there is there. And we will see soon how we can use that, but it's easier now to do that, to organize tests in inner classes. And there's another feature that goes really well with it, which is display name, where you can say, this might be an awesome name in my code, but maybe when I print the results, I want to have something different. So I can now say, is positive. Like the edit space is so much better now. But you can, of course, do whatever you want in there. And display name shows a nice name. And that works really well together. And I'm afraid you can't read it. Damn. So this is a screenshot from IntelliJ when I ran this. And so I have to explain now. Each of these bubbles is a new nested test class. These are the methods. This is a test class. This is a test class. Inner classes. And then you can name them really well. Let's look back here, where I can say, when this method fails, what I can see is a count. When greater 0 is positive, it concatenates those strings, and that test failed. And then I can see really well like what exactly happened. Another nice detail. People doing behavior-driven development might like this. Okay, what's new here? Yeah, where does it come from? I don't know. Let's see later. But I can't put parameters in there. Okay, so that covered the stuff that's new. So we saw that the lifecycle works much like before, or at least I told you that. Many small details were, I think, they were changed, and I think they were improved. Nested and display name work really well together to organize tests differently and making them very readable. There's parameter injection. And for all of you people who hoped you can now use fancy lambdas to really easily define tests, nope, you can't. Yet. Okay, that's great. But the title said this is the next generation testing on the JVM, so this is hardly next generation stuff, right? We'll see where we find that. Okay, I would take general questions later, but now, before we go to the next part, questions about what we saw just now? No? Yes? Okay, so the question is, does the new version support the old syntax of JUnit 4? Yes and no, and I will answer that question more precisely later. Okay, so when you wanted to extend JUnit 4.0 up to 4.6, you had just one choice. You had to implement a new runner, and a runner used to manage a whole test lifecycle. It has to do everything, which also means that your implementation can do everything. It's very flexible, but it's also very heavyweight, and this is the most problematic piece, it's exclusive. I cannot have 3 runners running my same test class. So if I want to have the Mockito JUnit runner and I want to have the Spring runner, then I'm fresh out of luck. So that wasn't nice. So in 4.7, another extension mechanism was introduced, which was called rules. Now you can do this. This is precisely the same thing that happened before. You could put this rule thing here, and it would get called, like JUnit would wrap basically everything that happens. So that means a single test method, but also other parts of the test lifecycle, would wrap it all in a statement, give it to this rule, and then it could do some stuff, like run it in a different thread or do some before-after. Much more lightweight, also more composable, but limited to certain kinds of behavior, which did not always suffice. And this also means that JUnit 4 has now 2 competing extension mechanisms. Each has its own limitations. There's huge overlap, where you wonder which one should I use. And the composition is not always clear how that works, and it does not always work how you might expect it to. So JUnit 5 picked a different approach. One of the core principles that you can see online is we want to prefer extension points over features. Which means we don't want to implement everything ourselves. We want to have very flexible extension points where users and also the developers themselves can add features. So quite literally, actually, JUnit 5 has a concept called extension points. These are them. You don't have to know them by heart. So they do stuff that makes somehow sense. So something's annotated with before all. Maybe you want to do something there. And something... for example, this parameter resolution that we saw, you want to do something at that point, and we can see now what it means to do something. But these are these points that are there currently. This might change. Like basically everything might change. So implementing extensions, for each extension there's an interface, and it has often just 1, maybe 2 methods. And these methods get some kind of context. And in the context is a lot of information. Like which method was it called on, which parameters are there, all kind of stuff you can access in here. So if I want to do something at before each, I would have to implement this interface. And if I would want to do something after each, I would have to implement that other interface. Of course, I can implement both, and then I can implement my new cool feature in one single class, which is what we do just, to get used to it. So say we want to benchmark our tests, and for each test method, we just want to write the runtime to the console. Very easy, nothing fancy. So when we think about it a little bit more, we realize before each test, we want to store the current time, and after each test, we want to see how long did it take. Very straightforward, and this is how it looks. We create our benchmark extension, which implements both of these interfaces. We have a field where we store the launch time, and then come the methods, which are these. I hope they all fit on the slides and you can all see them. Before each simply assigns the current time millis. The system dot is a static import, so you can read it on the slide. So this is system current time millis. It's assigned to the launch time, and then after, I just compute the difference between the current time now and the launch time, and put it into a nice string and print it on the console. So already we made our first extension. Quite easy, I think. Okay, now remember the disabled on Friday thing? Like, how does this work? There's an extension point called text execution condition. When I implement it, I get called whenever a method is about to be executed, where this extension applies. We'll see what that means in a minute. But if this method gets called, we do something very easy. We check whether it's Friday. And if it is, this condition evaluation result has a static factory method called disabled. So we call this, and we return a condition evaluation result instance, which tells JUnit, I want to disable this test now. And that's already it. That was fairly easy, I think. Okay, let's also look at the parameter injection. Here you have this extension point called method parameter resolver, and it has actually two methods. One of them is called supports. So if I want to, if my extension is going to inject this my server, which I showed earlier, then first it has to know that it actually can do that. So JUnit asks it before. Here I have this all kind of stuff that I collected from the test method I'm about to call. I give it to you to my implementation and ask you, do you support this scenario? I take the parameter out, check the type, see yes, it's a my server, I can do that. So I answer yes. And then later I will be called to resolve the parameter. To resolve the parameter, so to provide an instance, which I just do by creating new. And of course, here I can do whatever I want. Like, this can be incredibly fancy. All the stuff that goes in here that I get provided, as well as in the other contexts, contains the annotations that are on there and all kinds of stuff. So I can do really fancy things like check, is my server also annotated with something? And maybe you could even use reflection to find out what's the parameter called. So maybe if it's called, I don't know, Google server, I want to connect my server to Google. Otherwise, I want to connect it to whatever, Facebook. So you have a lot of ways to find out what's going on around you to react properly in your extensions. So, but how do we apply them? Now we talked how we implemented them. So I can just implement a class anywhere. It implements a bunch of interfaces, and that's nice. But how does JUnit know that it has to call them? And this is the regular mechanism. You just put an extend with annotation somewhere on the class or on your method, and you say with which of your extensions you want to extend it with. And this might work, but somehow it's very technical and verbose. It doesn't look nice. It also doesn't look like the disabled on Friday that we had earlier, which is much shorter and much more readable than this. So how do we get there? Meta annotations to the rescue. So annotations can be applied to other annotations, which is a little bit weird. I also managed to put annotation on the slide like 5 times, I think, or 4 times. No, 5. So, okay, so a lot of annotations. So it's very easy, though. You can apply annotations to other annotations. And JUnit knows that and checks that. So whenever it finds an annotation, it looks, hey, what is this annotation annotated with? And then goes further and further up the tree, tries to find all the annotations that are indirectly present there. This is the kind of hamstrung way to implement inheritance. if we would have inheritance in annotations, it would be much easier. I could just say this annotation inherits from these two, and then we're done. Doesn't work, and this is the way how you can fake it. But this means that we can create our own annotations, because JUnit is going to do this lookup thing on them. So we can have our own annotations, and they work perfectly within the JUnit framework, like it's theirs. So let's do that. We make this annotation, we call it disabled on Friday. And the annotation itself is annotated with the required extension. And just for fun, we make another one. We call it integration test, which will annotate with add test. We add this tag. I'm not going to talk about tags, but there are ways to filter later what tests you've run. And because integration tests take long, we want to definitely extend it with our cool benchmark extension we made earlier, and integration tests are all going to call our server. So here we add a bunch of stuff. And this means that whenever JUnit finds the integration test annotation, it realizes, hey, this is a test, it has this tag, and these two extensions automatically are activated for it and will get called at the appropriate moments in the lifecycle. Oh, sorry, I forgot the example below, down there. So now you can see it. I can do very easily, I can hardly read it from here. So you can say test login, and I need a server for that. And then you annotate it with disabled on Friday, because it never works on Friday, and the integration test, and that's all we need to actually have it run within JUnit. Okay, so we've seen that because of these many extension points, there is a lot of flexibility that we ourselves can use to implement our own needs. These extensions generally compose well, and due to those meta annotations, I can really use them in a way that look very much like they would be implemented in JUnit, so they don't stand out. We left out a couple of details. One interesting thing that we didn't see so far is how do I create tests dynamically, which means the way it is implemented now, you have to have all these tests have to be ready at the time JUnit starts running. So JUnit starts running and wants to see all the test methods. But maybe I have a case where I say, at runtime, I want to create these 5 tests, do them as well. This dynamic test generation is not in there yet. There's a big issue and pull request being worked on, and it will be there eventually, but it's not quite sure yet how that looks and what exactly it looks like. Okay, still great, but this is still not next generation, right? This is just incremental improvement with some stuff. Okay, so again, questions so far before we go to the next? Yes?
Okay. If I want, for example, to give to resolve some arguments, for example, I have 2 servers, and I want to, in different tests, to put, for example, annotation, which could specify what server I want to inject in my as an argumenter. How can I do it with the help of JUnit 5?
So I wish I would have put it on the slides. So the idea is there's already a very rudimentary Mockito extension written by the JUnit team just to show what this can do. And they use a different approach. While I put the annotation, let's go there. I put my annotation here on the test. What they do, you can put an add mock annotation here on the parameter type. And then Mockito knows, oh, there's the Mockito extension knows, oh, there's add mock annotation there, I'll do my thing. And then you could think that maybe you want to have a specific annotation for your case, which takes a bunch of arguments. And then you assign these arguments here, and then you have like my server 1 and my server 2. You annotate them very differently with very different annotation arguments, which also makes the text rather long, but still. And then you can use that in your own extension to create just the right instance that you need there.
Okay. So I can see it in Resolver, yeah?
Yeah, exactly. Yeah, these contexts that usually get handed in when we write annotations. This stuff like here, just put them 3 dots there, and here as well. There's a bunch of stuff that goes in there where you can query all kinds of things.
Okay, thank you.
Back there? Also, or in front here, whoever was first.
Okay, I have a question. For example, my extension can throw exception somewhere in the runtime. Should I handle it, or it's handled by JUnit, or I will see my exception?
Good question. I have to wing the answer. I don't know yet. I don't know exactly, but I'd say that if you throw an exception in the extension, I assume that JUnit catches it and just shows the test as failed, or whether it makes sense to actually do something which can cause exceptions in these extensions is, what I would say, is a matter of debate. I would guess that maybe not, because if you depend on like a file maybe that could fail, then the test is very unstable. But yeah, if that might happen, then I guess that you would just throw the exception, have the test fail automatically. Because here, for example, here is no way to tell JUnit like right now, shit, it didn't work, don't run this test. So here, if you would catch the exception, you could do nothing with it. I would guess you would have to throw it, and then JUnit would catch it.
Yeah. Okay. Thank you.
Okay. Many questions. You pick.
In your parameter resolver, you resolve only one parameter. Is it possible to resolve multiple? I see that you define a separate method for resolving of one parameter, and it returns only object, not an array of objects.
Yeah.
Is it possible?
So if I would have two method parameters on the same test method,
yeah,
then this, depending on how exactly I introduce this annotation, if I do it as we did now, like I annotate the test method, then it gets called for both parameters. Then maybe it has to find out whether it's actually in charge of both. If it's both in my server instance, it might want to create both. But if one of them is, I don't know, something totally different, it might say, hey, I can't deal with that.
So the same parameter resolver will be called for both parameters?
Exactly.
Oh, okay.
Okay, let's pick one more. I think the man in the back, sorry, the sir in the back had his arm up for a while. And then we can pick up more questions later. I just want to make sure that we can go through everything.
Maybe my question is some strange, but we have seen how we can check that exception was happened. But is there some possibility to check that exception don't happen? I can illustrate. For example, I create some language, some UNIT language, and I need to check that something parsed without problems. So I don't need to call exception because, for example, in anti-LR, it's parser generator. We need it because we don't anti-LR don't call exception with just say message, and after that I call exception with my code. So is there some possibility in JUnit 5 to check that exception not happens?
I think I couldn't quite follow. Maybe we have to ask me again afterwards. So in this code, you mean whether in this code I can check whether no exception happened or no?
Don't happen.
Didn't happen. Well, this is just your code. You can, of course, when if the exception gets thrown, it gets thrown. So you just don't catch it. Let's talk about that later. Okay? Great. Okay. So let's go to the architecture. Okay, JUnit 4 had something which can barely be called an architecture, at least on the jar level, because there was just one. Ignoring Hemcrest for now, it's just one jar. And everybody used it. The developers used it to write the tests against. Extension used it to implement classes and interact with the state. IDEs used it for all kind of nasty stuff. And there was not at all a separation of concerns. It was just all one. And while those tools we like IntelliJ or Eclipse, Maven, Gradle, they all have awesome features that we love, but the JUnit 4 API is just not powerful enough. So what do you do when the API doesn't do it? I don't know, I use reflection. That will solve everything. Now everything's better. And this was actually what people did. Developers of those tools, and they had no other choice. We want those features. There's no API, so this is the only way out they had. So I used reflection to get into the innards of JUnit and pull out everything, like private methods, private state, that would access whatever was needed. And this means that some tools are now bound to implementation details deep within some version of JUnit. If JUnit, if the team decided to change a minor detail, which is purely implementation detail, maybe the name of a private field, it could potentially break some tool which used that to find out stuff about JUnit state. And this made maintenance very hard, because you can imagine if you have to write code and you have always think about maybe all of these fields that I'm having here, not all of them, but some of them might actually be used by other tools. So this was a problem, and Johannes Link, which did a lot of development in JUnit 4 and also was one of the people getting this JUnit 5 thing going. Sadly, he left the team for no known reason, no publicly known reason. He quoted this when he started working on JUnit 5, that the success of JUnit as a platform, which every tool uses, prevents the development of JUnit as a tool that we developers want to use and have new features with. So JUnit's success was that it has great tool support, and JUnit's problem was that it had great tool support which did stuff they weren't supposed to. So JUnit 5 made a different approach. They said, okay, let's separate these concerns. We have an API to write tests against and a mechanism to discover and run tests. Okay, an API to write tests against makes sense. A mechanism to discover and run tests, but which tests, which was also basically the question we just asked. I mean, obviously we want to run JUnit tests, but which version? I don't know, 5, maybe 4? And can we only use the test annotated stuff? We want to have this lambdas finally, please. And so somehow this doesn't, we cannot answer all these questions with this one thing. So let's split it up further. We still have this API to write tests against. And this mechanism to discover and run tests consists of 3 parts. Each specific JUnit implementation, like 4 or 5, maybe 3, has its own mechanism that knows about these kind of tests. So this is one, it's called an engine. This is one engine that knows, I'm running JUnit 5 tests, I know how JUnit 5 works, so I can do all that stuff. But JUnit 4 could implement this differently. And then you need something which orchestrates these different engines. And then you also need an API between that, so it doesn't get too bound together. For JUnit 5, this means, or let's do it inverse. Let's first do the graphic, and then I'll explain it. It's hard to read. Okay, here are our tests. And this is the JUnit 5 API. This is a very small jar which just contains the test annotations and some very other stuff. It's really small and very has no dependencies. So this is what I use when I write my tests. Here's the JUnit 5 engine. It knows about the JUnit 5 API and can run those tests. And it implements something which is the JUnit engine API. And then down here you have all these tools which now want to run the tests. So what they do is they have some launcher that they can ask about how many tests are there and run this test or run that test, run all the tests tagged with integration. This is all part of that launcher's API. And the launcher will then ask the service loader, but that's implementation detail, it will somehow find all the implementation of the engines. So your tool goes to the launcher and says run all tests. The launcher finds out which engines are there and tasks those engines with running the specific tests. So here in text you can see it for JUnit 5, the API I just talked about, where we write tests against. We have the JUnit engine API, which all those engines implement so they can be called. This is the specific engine for JUnit 4. And this is the launcher who does what is written down there. It discovers the test engines. It makes sure that they're all executed. And it provides an API to build tools. So a clear separation of concerns, API for developers and for tools. And still, where's the next generation testing? I mean, come on, we're almost at the end of the talk and it's still not there. But this is it. This opens up the platform. This is the part that I find most thrilling about JUnit 5. Everything else we talked about so far is nice. It's a nice improvement of the tool that we use. But this can actually change things. Because we can do everything with engines. Like, you want to have a JUnit 4 test as well? Create an engine for it. You want to finally run TestNG with the full IDE support? Or maybe the big IDEs already support it quite well, but maybe you have a small tool which the implementer, the developer doesn't invest enough time to implement, to support any kind of testing framework. TestNG, Spock, built on JUnit, but still, like everything you can basically come up with, you can create an engine for it. For example, for our Lambda tests. And then it looks like this. So the same thing as before, but here we have the TestNG, which is totally not real. So please don't confuse this as a fact. It's not there, but it could be. JUnit 4 is there though. So here's the JUnit 4 jar, which serves as the API I write my tests against. But the JUnit 4 engine implements this engine API and runs those tests. So the answer to the question is no, the JUnit 5 does not understand JUnit 4. But there is an extension, an engine within the JUnit 5 ecosystem already now, which does. And it runs the JUnit 4 tests. So more engines can solve a lot of can give us a lot of the features that we want. And this opens up the platform. Once many tools support JUnit 5, the tools are decoupled from the implementation details. Not as before, where they were like, this is 4.12, and in 4.11 things were differently. So if your tool is going to support both, they may do some crazy hacks to find out which version is running. That's all going away. And tools can support all test systems equally well, because if they support the JUnit 5 API well, then new frameworks can just implement their own engine and just run inside the JUnit 5 ecosystem, and they have full tool support. Like if you have your own idea how to create a testing framework, great, you can do that now, and from the first minute your users will be able to actually use it within their IDE without doing any fancy shenanigans. And this might, I'm not saying it will, but it might actually give rise to a new generation of testing frameworks, because now we can try all this stuff out easily, and there is a chance of developers adopting it. Because no matter how great frameworks or frameworks, especially testing frameworks, work, if the tool support is bad, it's really hard to use them. If all I can see is like, if I cannot even get Maven to fail because the tests don't work, then what use does it make? Does it have? So now JUnit's success as a platform, if JUnit 5 is as successful, will become available to all the tools. And this might actually herald the next generation of testing on the JVM. I believe, and I hope so, that this will happen. Okay, so the real summary of the architecture is that we have a clear separation of concerns. This opens up the platform, and support gives this tool support to everybody. And again, this is not all. Like I skipped some details, like with the extensions as well. I skipped some implementation details, but that's the gist of it. Questions about architecture? Oh, do you need time to think, or? So the question was whether JUnit 5 contains the engine for JUnit 4. Yes. So it's just a separate jar. All of these things are jars. So are there? Yeah, I'm not sure, but yeah, these are decoupled as well. So all of these bubbles are jars, and this one exists. You don't have to use it if you don't want it. Yeah. Yeah. Next chapter, next section. Great question. Yes? Yeah, the launcher will just ask, so there's a service loader API. Sorry? Yeah, the launcher does not. So the question is, it was not a question, but I'm going to answer the fictive question is, how exactly does the launcher find out which engine to choose? But it doesn't. It finds the engines and it tasks the engines with, look, I was told to run all the tests in this folder. You go ahead and tell me what you want to do. And then the JUnit 4 engine goes through and says, oh, I found like 28 tests. And then the launcher will tell it, run them or not, whatever. There was, I think, also a question here. Yeah.
How easy will be for me to migrate to new JUnit 5? Can I just switch the version in my dependency system? Or should I done some work?
I will partly answer this in the next section, and if you, then there's still part of the questions left, then ask again, okay? So, because I think it will, yeah.
Okay. And what about engine supports? You have announced JUnit 4 engine, JUnit 5 engine. Do you have you spoke to another test frameworks, maybe Spoke framework? Or?
No, I haven't.
Okay. So,
but you're free to do that. That's interesting, because JUnit 5 now, it's, I think the project is going well on the code side, but I think on the publicity side, not so much. So if you have a favorite test framework and you think it should run with JUnit 5, ask the people supporting that framework. Say, I heard about JUnit 5, it's supposed to be awesome. What do you think? Would you consider supporting it? I think that would be a great thing to do.
Okay, thanks.
Okay, it's a last question. Sorry, but I think it was up here. And then, also, did you ask later? Otherwise, I'm around the conference. You can ask me anytime. It's up here somewhere.
Which minimal version of Java will be supported?
Good.
Because
Interesting.
Lambda.
Oh, sorry. Yeah, so exactly. The question is which minimal version is necessary. Currently, it looks like it will be Java 8. I mean, the code inside JUnit 5 already uses Java 8 features, which I think they could technically take out, but then the question would be, remember that assertion can take a functional interface. Now it's just the function that comes in, the supplier that comes with Java. But if you don't have Java 8, you don't have that interface. So if they would want to be backwards compatible, they would have to introduce their own interfaces. I would guess that they stick with Java 8.
Okay, thank you.
Okay, so let's talk about tool support for a moment, because there's not too much to talk about, unfortunately. So principally, if you want to write tests, it's easy. Just add this dependency. So org JUnit, JUnit 5 API, as I said, you only need the API to write tests. Pick 5.0.0 alpha or milestone 1, which is supposed to come out, I don't know, soon-ish? Like maybe this or next month. I think end of May was the original plan. And you can start writing tests. Okay, now maybe you want to run them as well. And there is no native support yet. There is an issue on Maven, which, as an outsider, looks like nothing is going on. I didn't find an issue on the Gradle issue tracker. IntelliJ made good progress. Actually, there was interaction between the developer and the developer at IntelliJ working on it, at JetBrains working at it, and the JUnit team. So it looks good. It may actually be an early access build soon. And in Eclipse, there are issues on both sides, in JUnit and in the Eclipse issue tracker, and some things happened. It's not quite clear how far they progressed. But keep in mind, it didn't even come out yet, and it should come out like maybe in fall. Worst case, JUnit 5 comes out next year. So it's not like, this doesn't mean that it's all dark and horrible in the future. I think they will make progress and they will support it eventually. So, but still we want to run it. What do we do? So now it gets tricky. Remember the run with from JUnit 4? Okay, there's an implementation of the JUnit 4 runner that is called JUnit 5, which can run JUnit 5 tests as part of a JUnit 4 run. Okay, so nothing of that fancy engine thingy that I told you about. It's just a regular JUnit 4 run, and this runner can run the JUnit 5 tests, which also means that you have to say public here, because otherwise JUnit 4 will not find this test. You can do this on any test class, which frankly sucks, or you can just do it on the package. So you can put a JUnit 5 test suite class someplace, annotated with a runner, and say which package or packages you want to run, because this is where your JUnit 5 tests are, and then you're good to go. You just put that somewhere in your test tree, and then you're ready to use it. Okay, now I can run it. What about build tools? The JUnit 5 team provided Gradle and Maven providers. They implemented them, but very, very simply, just to see that it works as a proof of concept. Maybe the teams will adopt it or implement their own. It's not clear right now. And the user guide from JUnit contains details as to how to use them. And you can use it from the console, if that's what you like to do. There's another project called the JUnit console runner. You can download it and run it like this. So you can just, if you write tests and you don't want to use any of this other stuff, you can use this, and you might also include this in other tools. For example, you could tell Maven to run from the command line this thing. Okay, so you can start writing tests right away, but tools have no native support yet. What I found for the toy project I'm using it on, the easiest thing is to just use it as, just put one JUnit 4 class there and have it run the JUnit 5 test as part of JUnit 4, and you're done. Okay, so this is the final summary. The API made some incremental improvements. I think contain a lot of thoughtful details. The extension model looks very good. There are still things that don't work yet, but I think they will be fixed. The architecture opens up the platform, which I think is the big bonus. And tool support is not there yet, but I'm sure of it. So, questions? Now.
Okay, so first one about the architecture is how well thought out is it? Will it be that we would have multiple competing standards, like, because you would be able to link up, like you said, TestNG and maybe other frameworks to it. So will we or will we not end up in a situation where other guys will be implementing their own infrastructure, or maybe going in deep again inside of JUnit to gather additional details?
I'm not developing any of those tools, but I would guess if I were a tool developer, I would welcome this possibility to slim down the code that I have to write to support all these different frameworks. I'm not saying that they will do that. It depends also, I guess, on how well the API actually functions. Because if the API would be like, hey, we can only cover 80% of TestNG's feature, then maybe that doesn't suffice, and then maybe they do the same thing. I don't even know whether TestNG even has the same problems like JUnit had. I don't know. So I cannot tell about the API. I didn't look at it into any meaningful detail, and I don't have all the use cases in mind. So I cannot really tell whether it's fit for all these cases.
Well, but that's a thing to consider, so we don't have a zoo of APIs afterwards in 1 year or 2 years.
Yep.
And another one from previous, with the new additional features, does JUnit support test ordering and test dependencies?
Okay, that's also interesting, especially for integration tests. Does JUnit give you a possibility for test ordering, or like TestNG does you didn't ask that, but anyway, for instances where the same instance lives through all the test methods? It was there in the prototype. They took it out for the alpha version, and they're considering to reintroduce it in some more obvious way that actually gives you a real possibility to say, this is not just a random test, this is like a special kind of, test, which I want to have the same instance for all test methods, and then likely also please call them in this order. This is one of the things that there's an open issue for that. I don't think that it will be in milestone 1, and if you like that feature, hunt it down the issue and upvote.
Yeah, because that's one of the things why we actually swapped to TestNG.
Yeah, I heard that that's often the case. So I hope that. Okay.
Thank you for your talk. From your point of view, what is the major disadvantage of JUnit 5?
The major from which role are you a developer writing against the API, or are you? Okay, I'd say JUnit 4 support is pretty good. So the tools you're using are not going to get much better, if at all. So I would say JUnit 4 and 5 will have the same kind of tool support. I always like trying out new stuff, so that's why I want to use JUnit 5 already everywhere. But somehow my company doesn't want to use alpha version software. I don't know why. So actually, we use it as work as well in a small project. So the point is, I think these improvements to the API, I think they're nice. Like the way you can organize your code with nested and display name and normal public, but these are not the main concerns. It's just nice to have. I think important would be how well are the extensions there, because we use many extensions for Spring, from a key to whatever. If these extensions are not there for JUnit 5, that might hinder your migration. But since both can live in the same project very well, you can just start trying it out. You can just say, okay, for these new classes in this subpackage, I'll just try JUnit 5, come up against its limitations, open issues, try to work my way around it. So it's definitely worth trying it out in a small area.
Thanks. Thanks for your talk. And I understand the focus is more on the platform, but still I would like to see some improvements in the JUnit itself. For instance, one painful thing in current version of JUnit is the parameterized tests for me. So I love the way TestNG implements the parameterized tests, and I hate how JUnit does it because, you know, this weird arrays and the constructor, and I cannot kind of mix test methods, parameterized test methods with non-parameterized test methods within one class and so on. So are there any plans in this direction?
So this belongs to the dynamic test generation in the end, because if you can easily and dynamically create tests at runtime, then you can easily give users the possibility to, for example, say create 5 instances or create as many instances as you want of this test class, and I promise I run all the tests on them or something like that. So I think that's a prerequisite, or that's a way to solve it, to make like a more general case out of it. And that's what they're working on, and I hope that they will find a good way to support exactly that, because yes, that is painful. I totally agree. There's also front here, the next. Yeah, sorry.
Thank you. Can you tell a few words about stability of JUnit 5 API? As at alpha, I understand something can be changed, and if it can, what exactly can be changed in future?
You mean in the API? Or?
Yeah, the API.
Okay, that's interesting because first of all, we're slowly running out of time. If the mic gets taken away from me by force, just find me around the conference. To answer the question, this is what I said, that there's more down here somewhere. There's even more to the story. One part of the story is that the API is a life cycle. They're annotating everything, which an annotation, I think it's called API actually, and it has like a parameter which is called experimental, supported, and levels in between there. So when I use part of the JUnit API as a tool developer, for example, I can see which part is how well supported. For example, the extensions thing I showed you, they're all still marked as experimental. So if I were to write a Mockito extension based on that, then the JUnit team can still just change it. And the promise is that this time they really won't care, which I think they shouldn't. Like, they marked it as experimental and they shouldn't care if it breaks something. Let's see where that happens. Okay, last question? Yes.
Just a short question about category and tag annotations. Are they, looks like this comes with the same functionality?
I didn't check that out in JUnit 5, I have to admit. There's this tag annotation. And exactly the tag. I don't know about the category, and I don't know whether there is anything else than tag and how exactly that part works. So sorry, I cannot really answer that. Okay, great to have you here, and ask me later. Or, I don't know. You're timing me, so you tell me. Okay.
Thanks. Does it work? Oh, okay. I have actually 2 questions if you have time. Maybe you can still answer on that. The first question about nested classes. You introduced 2 methods, before and before all. I don't know, maybe that's about it. For instance, I have a class which is nested, or I have several nested classes. And I would like to do something at the beginning, create some instance, for instance.
Yeah.
And it should be executed before nested class objects.
Yeah.
For instance, I have a class, and in class I have methods, and I would like to test these methods. And for these methods, I created nested classes, and the instance of the class, I would like to use the same. How it's in
So the nested classes cannot be static. So that means that the nested classes always hold a reference to the outer class.
Yes.
But that also means that you cannot put static methods in there. So no static methods in nested classes means no method that you can annotate with before all. So you would have to do that in before each.
Okay. And another issue that I have about parameterized objects. And for instance, I would like to test a method which can return some value and return an exception, throw an exception actually. And I have given values and I have expected values. So using annotation like expected and...
expected goes away. Expected is gone.
Yes, okay, for now I assert exception, okay. But in this case I have to do if exception in throw, then assert the exception, otherwise check the value, you know, the problem.
I would argue that your test method should test either or, and you should know when you write it.
It should test results and it should also test exceptions.
Yeah, that's more like a how do you design test thing. I would say that your test method should be set up in a way that it definitely doesn't throw an exception, or if it does, it fails, or you write. So. Okay, so thank you very much, everybody.
Thank you.
Bye.